to Blender Sushi Live Nerding. In this episode, I want to talk about a simple algorithm that's available inside geometry nodes, but I need to explain it using SVerchok nodes because it's much simpler in SVerchok. So yeah, the algorithm is basically connecting the dots, right? If you have a bunch of points, you want to be able to quickly connect the dots, and sometimes you also want to be able to find the closest edge connecting the dots. Okay, so it seems simple, but I'll explain anyway. So in SVerchok, if we want to have random points. I'll do it this way. Okay, random vector, just plug into this viewer draw, and I can create random points, right? In SVerchok, if you make random vector, you get this spherical result, which you might think is a little bit weird, but it's just the nodes that does this. We can use a randomizer, so we randomize the points a little bit more. So now we have like a point cloud. Let's simplify this, maybe 100. Okay, 100 random points. And if you want to connect the dots in SVerchok, UV connections. And yeah, this simple node does a little bit of algorithm. It's gonna try to connect the edges. Okay, so now we can sort of find the edge that connect each and every dots, no matter if I randomize the original points or not. Okay, so let's save this. So random points connect the dots. If you want to do the same using geometry nodes, I will show you in a little bit later. So this is just connecting the dots one by one. Okay. If you want to connect, if you want to have like edge connecting every points, you use another algorithm. In SVerchok, I know we can use KD3 closest edges. I think that's the one. So random points, bring in the vertices, and the output's gonna be random points being connected together, and we can control how many points actually get connected together, so we can increase the maximum numbers. So there is a couple of algorithms that we can use. The fast one simply just trying to connect everything based on maximum distance, so it's really super handy. You can control the minimum and maximum distance, and there's no skip complete. You can try this yourself. Normally, to see this simpler, probably use a circle, just a basic circle. So with circle, we have points inside the circle, and then if we use the closest edge, we're gonna get this pattern that's looking more or less like something you see on the bike, on the wheels of the bike. So if you have two circles and you want to have all these connections between the 2 points, you use this kind of algorithm. So the minimum and maximum distance also matters, and you get this mandala pattern if you connect every dot, if you use the fast one. But feel free to play around with this, and you can also skip the points, so you get, like I say, like a bicycle wheels kind of wiring. So this is so we have two algorithms. The first one is simply just connect the dots, right? The second one, make edges on for every dots. For this one, there's actually a nodes in geometry nodes does the same thing. I will show you. I will need to use this node 3 from Higsas actually. So you might need to purchase this one. But the blend files, I got it from Higsas. It's only, I think it's only $5. But this is like a node 3 that generate points. So we have a bunch of nodes here from Higsas. The one that's connecting the dots, I have to find distant edge. Is it? Maybe I can just shift A. Connect points. Yeah, that's the one. So this one comes with Higsas blend files. So someone already did a hard job for us. You can recreate these nodes yourself, but maybe I just show it to you. Okay. These nodes alone is actually quite, it already has value because now you can use mesh circle geometry and then, you know, connect the dot. It's as simple as that. But I know, yeah, like I said, it's like simple because someone already do this for you, but there you go. Connect the dots of every points. Pretty cool. I think if you have two circle combined together, mesh join mesh. Oh, okay, join geometry. Okay, join geometry. You have two circle. What's gonna happen? There. I really like this one. Super simple, but also useful. See, you might actually want to, if there is a way to invert the vertices, we can get the lines that makes, you know, connects the two circles, the wheels for the bicycle wheels. I think that's how the algorithm works. Anyway, it's a, so if we go back to SVerchok, I want to show one more algorithm. I think this is kind of related because they're related. I need to show you at once. I used to have a couple of videos talking about the same thing, but anyhow, in SVerchok it's much simpler. So we did the closest edges. Now we want to look at closest vertices and closest path. If you have 2 points, like if you imagine planet Earth, or like if you are using Google Map, you often want to find the closest path between 2 points, A and B. You know, you want to go to one place, you want to find the closest path or how to get there by car or walking. This is the kind of the algorithm. But like this is like a really low level in a way, so it sounds really complicated. But yeah, let's see. Remember our, okay, let's don't use this for now. Just take a look at this KDT closest path. We have bunch of points. That's spherical. Or I can randomize further because this is in SVerchok. So we can connect we can find the closest path, and we can pick starting index and also the maximum distance. I think the larger is going to be slower. So this is the result. If you don't want to see the points because it's too messy, just hide the display vertices. So we get something that looks like a star in the sky. You know, if you look at stars, if you study astronomy, sometimes the astronomers gets really creative. They look at stars. Okay, that thing looks like a fish, or let's call it Pisces, or that kind of thing. Because they look at stars so many times and they see like a patterns, and they decided to make this. So there's algorithm going on in SVerchok. It's really simple to do. I mean, to find this kind of thing. There's also this KDT, closest vertices, and get through this one. I believe this one. Okay, let's plug all the points in there, and then we have a vector here, and then we want to find the closest vertices. This is how you can find the closest edges. So let's pick index there, plug in there. I think the setup is correct. There. This algorithm find the closest edges between points. And we can, with this example, we can have like a fine range within radius. If I increase the radius, it's going to be slower and slower. But this find the closest path between 2 points. It's much simpler. You can do the same thing in geometry nodes. It's just a little bit more complicated. There are actually an example by for example, by Kuldeep Singh, this one. You need to watch this video. So the closest path, I think it's using the shortest edge path in geometry nodes. So, but the node, I found the node is a little bit complicated to use. In this case, Kuldeep Singh explain it. If you want to make like lightning effects, because lightning effects, the lightning tries to find the shortest points into planet Earth, right? And so it's creating this lightning kind of effects that you often see. So this is the algorithm for lightning strikes. And I don't want to make the same video because Kuldeep already explained it, and then you can download the blend from his Patreon. Anyhow, in SVerchok it's kind of free, but you can actually dig inside the nodes and then finding how this done. But anyway, geometry nodes has its own edge finding algorithm nodes. Okay, so yeah, let's just save this again. This is SVerchok finding edge. This is also kind of useful if you have like a robot with 4 legs or more legs. The robot usually, if it wants to move on the surface, and then it needs to place the feet on the shortest path to the ground, right? So I think there's another example already out there somewhere. I need to find it again and show it to you, to create this kind of effects of spider walking on the wall. The spider, of course, need to maintain the space between the body. I mean, the body has its own like a joints, so the legs cannot go too far. It's like, okay, like a human, if it is our legs and we are walking, in order for us to move, we need to find the shortest path from our legs to the floor, so we can make a movement, we can make a motion, and we don't fall down. Okay, so similar thing with the spider, or if you make any kind of robots, I think it's using that algorithm as well. We are doing it in CG, or if you are using Unity or Unreal in the game engine, you probably use similar algorithm as well. I think it's already there, but I just like to talk about it in Blender. So one more from Erindale. Actually, if you want to connect the dots, connecting the dots should be really simple, but in order to do this, in geometry nodes it doesn't come with it, but you can do the same. You can actually do it. I will show it to you. Erindale toolkit. This is actually, I believe it's free, but I don't know. I think you make one time payment and Erin will update the blend with all the nodes. There's this one, points to Bezier. So it points to Bezier. You really can connect the dots. Okay. It should be simpler, but anyhow, this is just how it is. Okay, this is points, and we need to randomize the points, so we need to use random value. I don't know why I have random points group here. This random points actually does the same thing. Create random points on random vector position. There you go. We need to make this vector, this one. Plug the value. Now we have random points for sure, and if we want to connect the dots, we use ETK, random points. Yeah. Make resolutions to 1. Turn on and off cyclic. I think there's a bugs. There might be a bugs. I don't know. In these nodes, the cyclic sometimes slightly unpredictable. But the idea is there basically. So it's just like SVerchok one. I have to show it again. If we have vector B field anyway, UV connection, mesh viewer draw or mesh viewer. Let's use mesh viewer. Plug the points there, turn this into edges, connect the edge. Let's move this to the side. There we go. Random vector. Plug this in. Okay. Same thing, same algorithm, but just SVerchok does this much simpler. It's just like a one process. But with geometry nodes, of course, the way it is seems to be more complicated. But you can do more because it's with geometry nodes, it's gonna have to deal with particle simulations and maybe hair simulations. So it gets really complicated unless you can go really like low level. But with SVerchok, you can do this. It's like it's for different purpose, I guess. So this is Erindale nodes. So I found, someone already do this for you, right? Oftentimes you will find this because Blender is open source and a lot of artists, developer out there, and they're also sharing and they're also selling assets online. Very likely everything's kind of merging together. Obviously you can rebuild this yourself. You can start from scratch and make your own version of this. Erindale give one example. It's just like connecting the dots, right? Maybe geometry nodes needs to have connect the dots. It's kind of have this edge neighborhood, edge path to curve, and all this very low level nodes that you can use. But I think Erin use index positions, curve to points. He uses the sample index actually just to connect the dots. Anyhow, we can get this for free. So this is connect the dots. So connect the dots, we talk about connect the dots, find the shortest edges, find the shortest vertices, and then all those. And also this example, I need to watch this video actually. If it's 20, it's almost half an hour for video explaining about this lighting effects. So you can try build this or just buy the blend from Kuldeep Singh. So like I said, ideally, of course, ideally we have some kind of AI or like a search, not just a search. Like if you want to make lightning, you want eventually you want to have tools in a form like geometry nodes, like procedural tools, just to create lightning, right? Down deep in the setup, there's some kind of algorithm, and the algorithm is a little bit abstract. It's already there on the internet or it's on the books that you can read, and someone can explain the algorithm. I cannot really explain the algorithm. I can use the nodes, as you can see here in Blender. Yeah, I can use SVerchok because SVerchok actually comes with a lot of, with hundreds of nodes. There's a lot going on with this, but anyhow, what I found, um, so the knowledge should be like out there somewhere, and someone with the AI at least, eventually we can just search what we want and we can get it, right? But of course the problem nowadays is like, okay, but if I create that tools or assets, how can I get a value out of that? Because but yeah, if you work in a company, for example, for a long time, you make assets and tools, and then the company will own that assets. You know what I mean? So it's kind of like we are building with Blender open source. I think Blender artists actually, whenever they share knowledge, it's gonna be other Blender artists can take the blend, open the blends, maybe make modifications just to suit whatever purpose they're using for their own task or projects, or make, yeah, and so on and so on. So I don't know. It's a question. Once a person share it, everyone can use it. Will that person get the value, out of it? There might be a need for someone who can actually use the tools and use it in the projects, but yeah, and one person cannot do everything. You know what I mean? You need like a team in order to complete a certain task. But if you are, even like if you're just playing video games nowadays, and then you want to kind of, there are certain tasks that you cannot do it alone, so you need a group of, you need a team in order to complete the task. I know it sounds very simple and philosophical, but like if in the future we can just ask AI, the AI will tell, okay, you need these blend files from the AI that's smart will actually still kind of source the original, like what I'm doing here in the video. I'm showing you, okay, this if you go to this video by Kuldeep Singh, okay, you can create this lightning effects. You can do the same thing using SVerchok maybe, um, but anyway, you want to do it inside geometry nodes because it comes with Blender by default, and and so on. But anyhow, this is just the super very basic one. I like to talk about this, and I want to put this inside the books. That book, hopefully, if it's it's becoming like a, not like a Bible of Blender, no, but because more maybe like a Wikipedia. Like a Wikipedia also, Wikipedia knowledge is all free for everyone. It's like open source. Then the AI that can read Wikipedia is becoming another level of, like a machine helping human to answer the question. That's basically what it is. It's connecting the dots and trying to find the link. uh yeah, anyhow, that's all I want to talk about. It's just very basic, connect the dots. I talk about this in my previous videos, but I just want to bring it back. So hopefully you find this useful. Thanks again for tuning in, and I'll see you next time. Thank you. Bye.